channel Tech Tic Tac Toe. Today we will discuss about queue in detail with codes. We have discussed about the concept of queue in previous video. I will give you the link in the description portion of this video. You can see it. But now there is a small reminder, that is queue is a linear data structure. Here insertion at one end and deletion at other end. So insertion will be here, new item will be inserted after that, and deletion will be from this end. This is FIFO, that means first in first out. The item first inserted, the item will be the first item to be deleted. Real example means, real examples we can say that a line or a queue in front of any counter. The man who came first will serve first and can go from the queue. So this is a real example of queue in front of any counter. So in this way we can implement this in array. Now the main concept of queue is NQ operation, that is insertion in queue, DQ operation, that is deletion in queue, and front means from where we can delete, and rear, tail, that means from where we can insert. We can implement queue using array or linked list. Using array it will look like this, and using linked list it will look like this. We will discuss this in detail. Now queue using array. So this is the picture. Here we have a queue with 4 elements. Now we want to insert a new element 10, and then we insert new element 5. So NQ operation, that means insertion in a queue using array. First we have to check if this is a blank queue, that means there is nothing in the queue. So if rear equal to null, that means it is a blank queue. So then we will initialize rear to 0, front to 0, then queue is the array. So queue of 0 means first position will be the new element. So this will be done for this new element. If this is not the empty queue, if there are something, that means if the queue is full, that means if rear equal to size minus 1, here size is 6, 1 2 3 4 5 6, and rear is the position index of the array. So size minus 1 means 0 1 2 3 4 5, rear will be 5. So if rear equal to size minus 1, then we will print queue is full, so we cannot insert any new element and we have to exit. Otherwise, if it is not null or not full, then we have to put the element, that means this is our rear will be 3 here, 0 1 2 3. So rear plus 1, that means 0 1 2 3 4, fourth position, queue of 4 will be the new element, and then we update rear to rear plus 1. So now rear is 5. After inserting 5, rear plus 1, this will be the new place to insert new element. It will be rear plus 1, that is 5, and rear will be updated to 5. After that, when we again want to insert, then the rear will be 5, that means size minus 1. So it will print queue full, then cannot insert anything more. So this is the insertion. This is the way of insertion we can done using array in the queue. Now queue using array, the DQ operation. In DQ operation we have to delete. So first we have to check if it is a blank queue. So front equal to null. Front equal to null means it is an empty queue. At first front and rear both are null when there is nothing in the queue. Now if it is not null, there is something in the queue, then we can store the variable, we can print the variable, whatever we want to do we can do with the element we want to delete. This will be the front first. So this will be the front, so we will store this in the variable v. Now if front equal to rear, that means it is the last element in the queue. That means if it is this position, if there is only one element, front equal to rear, then we will set front equal to null, rear equal to null. That means there is nothing in the queue. Or if the front is not equal to rear, that means else part of this will be front equal to front plus 1. That means here after removing this we will set front equal to here. So now front equal to here and rear equal to here. After removing 30, front equal to here, rear equal to here. After removing 24, front equal to here, rear equal to here. Then we can store this at v, then front equal to rear, then we will set that after deleting 86, front equal to null, rear equal to null. That means it is an empty queue. So this way we can dequeue or delete from the queue using array. Now queue using linked list. In linked list we do not have to check if the linked list is full or not, as linked list can be extended as much as we want. So now first we have to set a new pointer, that will be the new node. So new node means there will be new info and link. So new node will be new pointer. New pointer dot info will be the new element, that means 10, and the link portion of this new pointer will be null. So this we set. Now if rear equal to null, that means the queue is empty. Then front equal to new ptr, rear equal to new ptr. That means both of them will set to this cell. Otherwise, if there is something in the queue, that means this is the queue previously we stored, then rear dot link equal to new ptr. This will be rear dot link, here link will be the new ptr. So address of 10 will be here, and rear will be set to the address of new. So this will be the new, this will be the new rear, and here this will be the previous rear. Previous rear's link will store the address of new ptr, and new ptr will be the new rear. So this way we can insert one item in linked list. In dequeue operation we have to check if it is a empty queue. So if front equal to null, then it is empty queue. Otherwise we can store the info part in any variable and do what we want to do. Then we have to check if front equal to rear, that means it is the last item to be deleted. If there is one item in the element, so after deleting this we will set front equal to null, rear equal to null. Otherwise front equal to front dot link, this was the front. So here we will set the link of this part to the front. So front will be now address of this portion, so this will be deleted. Front will address this. So next time when we want to do any deletion, front will denote this portion and this will be deleted. and when we delete the last element we will set front equal to null, near equal to null. I think you all understand. If you have any queries or need any detail, let me know in the comment section. If you like this video or find it useful, subscribe to my channel. Thank you for watching this video.